Alright, let's continue with chapter 5 about functions. Today with this exercise 5e, we're going to look at what we call a piecewise defined function. Um, Functions which have different rules for different subsets of their domain are called piecewise defined functions, and they're also known as hybrid functions, which is a term that we'll use more often. So to reiterate that, over the domain, you will split your domain into subsets, and for each subset, you will have a different function or a different rule, and that make up your hybrid function. Let's look at one example. Again, you need to be familiar with determining the range of your function, so by scanning your graph. Alright, so look at this example. This is a piecewise defined function. You can see the domain. If I take all the x's values, it's all the negative from 0 to 1 and greater than 1. That is your real number set. And it was done here, it splits into three subsets. So the first subset is x is less than 0, so 0 is excluded. The next one is it's between 0 and 1, and 0 and 1 are inclusive. And for the last set, it's anything greater than 1 with 1 excluded. Okay, and you have three different rules which are linear functions. So with linear functions, you need to be familiar with using the graded value to find the rise over run, and you need another point. Usually here you will use your y-intercept, and then finally you will need to determine the range. So pause the video, have a go at sketching quickly this function, and then we'll go over the solution. Alright, here is my function in a corner. Here is the actual result of the sketch. They annotated some specific point which are the intersections of the different rules. Okay, so let's break down the different parts of that hybrid function. With the first one, y equals negative x minus 1, you draw your straight line. That's a y-intercept of negative 1, and it's the gradient of negative 1, so that will be in yellow. As if I was extended completely over R, it will continue to be my first rule. Now it's only restricted to x less than 0, so here is in yellow the equivalent. Now at the end here, because x is excluded, in yellow I will have a yellow circle which will be empty. So that would be the strict way of doing it. Because we have the next section where we're going to include it, I don't have to worry about it. So that's the annotation. Note that when x equals 0, y equals negative 1, and it's not for this rule, it's coming from this rule where 0 is inclusive. So now for this rule, we include 0 and 1, and the rule is 2x minus 1, which is drawn in green. So notice how I put a fill circle at the end, and I indicate the coordinates as well. Okay, and lastly, this is the last rule, so that's why remaining in red. We have this rule, which is the slope is slightly lower as it's a gradient of 1 over 2, and the y-intercept, if I extend the red curve, it should intersect at 1 over 2 here at on the y-axis. And then from scanning the graph, you should be able to see that the lowest value on the y-axis, so let me see. What I like to do is I look at the function here, and I'm gonna what I do is I do something like that. I basically shade whatever the y values are acceptable. You can see the lowest value is this one, which is your -1. Therefore, the range is from -1 inclusive to positive infinity. All right, and that's pretty much it about 5e. And I'll see you in the next video.